Hello friends, very good morning to all of you. So today we are going to discuss PF54 part 6, that is theft of tokens. Like in the previous session we talked about theft of authorization codes. In this session we'll talk about theft of tokens. Yeah, so let's begin. Discuss theft of tokens, that is part 6 of this client vulnerability section. So in the previous section we talked about the theft of authorization code and we understand what is the problem if the authorization code can be hijacked. Same thing, we can just talk about the token. So let's begin. So the ultimate goal for an attacker that focuses their attention on an OAuth aware target is to steal an access token. The access token lets the attacker perform all kinds of operation they were intended to be able to do. So we already saw how OAuth client sends access token to resource server to consume APIs. This is usually done by passing the bearer token as a request header, that is the authorization, and then getting access to those APIs. So RFC 6750 defines two other ways to pass the bearer token along. One of those, the URI query parameter, states that client can send the access token in the URI using the access token query parameter. So there is a way. The one way that means you are just passing the bearer token as an authorization header and then you are consuming those APIs. So other way is like to use this URI query parameter and this pass the access token in that. Let's see how it is. So although the simplicity makes it use tempting, there are many drawbacks to using this method for submitting the access token to a protected resource. In this case, the access token ends up being logged in access.log files as part of the URI. People tend to indiscriminate in what they copy and paste in a public forum when searching for answers. And that is a risk, right? Like Stack Overflow. Maybe you just put that and your token is linked there also. Maybe the token is validity is for definitely for a lesser time as the security standard, as per security standard, we're just putting as of for 1 hours to 2 hours max. But yeah, still there is a risk there. If you put by chance the address in the some public forum where you have the access token exposed. This might well end up having the access token being pasted in one of these forums through the HTTP transcript or access URLs. There is a risk of access token leakage through the referrer, similar to one we have seen in the previous section, because the referrer includes the entire URL. That means using referrer, you can just get an access to that access token. So you access the one application, and when you're surfing to another, through the referrer, you can get access to those information. The access token, basically, if that is crafted in the URI as a query parameter. So this last method can be used to steal access token. Let's assume there is an OAuth client that sends the access token in the URI to the resource server using something like the following. So you have OAuth api.com/data/feed/api/user.html with the query parameter access underscore token is equal to something. So that means the access token here you are passing in the query parameter, not like by using the authorization header, what we are doing usually, what we have seen in our previous example. But there is a way also you can pass in the query parameter. So if an attacker is able to place even a simple link to the target page, that is the data feed API user.html, then using the referrer header will disclose the access token as shown maybe in this below diagram, as you can see. Right, so client accesses a protected resource with the access token in the URL. Protected resource returns an entity causing the client to fetch a resource on the attacker server through redirect or embedded items. Client follows, redirects or fetches item placing the protected resource URL including the access token in the referrer header. And then it can be easily hijacked. So using this standard authorization header avoids this kind of issues because access token does not shown up in the URL, right? In the case of authorization header. That means you have an API, you're just passing the access token as authorization header. So in this case, you are avoiding this. So again, you have some way, but in generally, in the industry, people are not practicing the vulnerability way, but at least you need to know if someone is using or someone trying to use, you can stop it. Although the query parameter is still a valid method for OAuth, clients should use it only as a last resort and with the extreme caution. So there is a way. It's not there is not a way you can pass the API using the query parameter of access token, but yeah, that's a risk we understand now. Correct. So I think there is some mentioned here in Jan 2016, a security advisory was posted to the OAuth working group mailing list describing an authorization server mix-up discovered separately by researchers from the University of Trier and the Ruhr University Bochum. The attack might affect OAuth clients that have client IDs issued by more than one authorization server, effectively tricking a client to send secrets from one server to another malicious server. So as a temporary mitigation, what we can do in this case, so client should register a different redirect URI value with each authorization server. This will allow you to differentiate between requests without getting callbacks confused. So in this case, what happens? So you have registration of the client at two different authorization server. So it get mixed and then it shared one information to another, and it just cause a malicious issue. So to avoid it as a temporary mitigation, what the people did, they just allow the client should register a different redirect URI value with each authorization server. So you have two authorization server for one instance. So you have configured different redirect URI for two different authorization server. So this will easily allow to differentiate between the request without getting callbacks confused. So if you have the same redirect URI, then yeah, it can be confused and it can just send, and then yeah, maybe some information can be leaked in this way. So that's happened in Jan 2016, what people have seen. So in this case, like effectively tricking a client to send secrets, including client secret authorization code from one server to another malicious server. Okay, so these are the things, right? So we know these are the ways through vulnerability can come. This we know maybe, but there are some other things people have discovered maybe in some time, in new time, right, in coming time. So we need to understand those part also, because in security you can't save everything. You can mitigate things. You need to know from where the chances are there. I can mitigate. I cannot stop everything, because it can be in security. You can't stop everything, right? You can't say a system is 100% secure, at least, but we can just we can just find an option where there is a chance of vulnerability, and we can prevent those by putting some practical implementation as we discovered. Correct. So yeah, let's jump to the next section where we'll talk maybe on the native application based practices, and then we'll just end this OAuth client vulnerability, and then we'll go to the protected resource vulnerability. Yeah, so if you have anything, please put in the comment section. Thank you.